Welcome to today's lesson. Today we will be able to find the equation of parallel, perpendicular, and the perpendicular bisector of lines. We will be able to explain how to write the equation of parallel and perpendicular lines. So let's take a look at today's do now. Let's take a look at today's do now. We have what is the equation of the line that passes through the points 5, 2 and -8, -2 written in general form. So I'm going to let you guys try this problem out and we will compare our answers. Okay, so for this question, the first thing we have to find is the slope. After we find the slope, we pick one of the 2 points to get it in. I used the point gradient form. From there, I changed it into the general form, which is that ax plus by plus d equals 0. And as we have said before, we cannot have a negative a, so I had to multiply everything by a -1. But b and d can be both positive or negative. They are part of the integers. Let's take a look at today's thinking. What is special about parallel and perpendicular lines? So we have parallel lines versus perpendicular lines versus perpendicular bisector. Parallel lines are lines that never intersect and lines that have the same gradient. So visually, these would be considered parallel lines. They never intersect and they have the same slope. So here we have, if line 1, L1, has a slope of m, that means that the second line, L2, will also have the same slope. Perpendicular lines, on the other hand, do intersect. Okay, besides their intersection and having a 90-degree angle at that point of intersection, their slopes are negative reciprocals of each other. So if I have line 1, L1, have a slope of m, that means that line 2 or L2 will have a slope of -1 over m. And then we have something known as perpendicular bisectors. So they are similar to perpendicular lines. They are going to intersect. They are going to create this 90-degree angle at the point of intersection. But they are also going to be intersecting through the midpoint. Okay, so super important. These types of lines do intersect and they intersect at the midpoint. So let's try some of these problems out. Okay, so let's take a look at this example. We have write the linear equation of f of x in general form, given that the line passes through the point -2, 10, and is parallel to the graph of g of x, which is -4 over 5 minus 3x. So we want to write this equation f of x in general form, which represents ax plus by plus c equals 0, right? So before I do that, I need to identify that we're writing a parallel line, meaning that we are going to have the same slope as the original line. So the slope of the original line is actually -3. Knowing the fact that I have that slope, I am going to substitute it into my slope-intercept form. And what I need to find out is what is the value of C, the y-intercept of this parallel line. So what we need to do is take that point -2, 10 and substitute it into our y and into the x value so we can manipulate this and solve for C. And we get a value of C is equal to 4. So we're going to put this together and write our equation. F of x equals -3x plus C, which is plus 4, but I want it in general form, which means that the x term is going to come in front of y, the constant in back, and I'm going to set it equal to 0. Okay, so I wrote my equation 3x plus f of x minus 4 is equal to 0, which is similar to 3x plus y minus 4 is equal to 0. Make sure 2 facts for the general form, no fractions, and your a value, your coefficient for x must be positive. So here, luckily, we didn't have to do any extra work. Let's look at example number 2. Example number 2, perpendicular lines and perpendicular bisector. So for question 1, write the linear equation of d of x in point gradient form given that the line passes through the given point, -5 2/3, and is perpendicular to the graph that has been given, which is 2/5 y plus 3x is equal to 4/3. So the first thing that we want to do here is get the original line in terms of y equals. That way I can determine the slope. And since we're dealing with perpendicular line, we want the negative reciprocal of the original slope. So let me solve for y. Okay, so I have my equation y equals -15/2 x plus 10/3. What we want to know is the slope, which I know to be -15/2, which means that the slope that we want is 2/15. Now that we have that slope, we're going to use that slope and write it in this point gradient form. We are going through this given point, so I'm going to just write my point down. My point gradient form is always y minus the y value of the point equals the slope times x minus the x value of the point, which would be -5. And I'm going to clean this up and write my y in terms of d of x because that's what they wanted. And my equation is d of x minus 2/3 is equal to 2/15 times x plus 5. Let's take a look at this next one here. A line containing the points a, -4, -2, and b, 8, 4 is formed. Find a, the equation of f of x of the line parallel to the given line passing through the given point in general form. And part B, write the equation d of x, which we are dealing with the perpendicular bisector to the given line in gradient intercept form. So we have 2 questions here, starting with the original points A, B. So first thing we want to do is find the slope, because once I find the slope, I can identify same slope parallel lines. Perpendicular lines have negative reciprocals. So let's find the slope. Now that I found the slope to be 1/2, I am going to start with part A, which we're dealing with the parallel line to the given points A and B, going through the given point 1/2, 3/4. So we are going to write it in that general form. I'm going to start off by writing it in slope-intercept form and changing it from there. Okay, so for part A, first thing we did was find the slope. We know that we are dealing with parallel lines, meaning they have the same slope. I plugged in the information as I knew it in my slope-intercept form. I substituted the given point, which was x being a half and y being 3/4. I solved for my y-intercept, which I found to be a half. Once I had that, I plugged in the information in the same form, gradient intercept form, slope intercept form, and then I changed it so I have it in that general form. Again, in the general form, we don't want any fractions, and we don't want that a term to be negative, or the coefficient in front of x to be negative. So I multiplied everything by 2, but also by that negative. So -2, simplifying it to my given answer. For part B, we want the equation of d of x, which is the perpendicular bisector to the given line, in gradient intercept form. So the first thing that we want to do is we want to identify the slope that we have to work with. And our slope is going to be -2. The original slope was 1/2. Negative reciprocal would be -2. The next thing that we want to do is we want to find the point that this perpendicular bisector is going to intersect. And the point is the midpoint. So step 1 is find the slope. Step 2 is find the midpoint. So I'm going to use my midpoint formula and I'm going to solve for the midpoint. What point are we passing through? So using my midpoint formula, I found that the midpoint is 2, 1. So this is the point that we're going to use into our equation and clean it up. So step number 3, we're going to write the equation using the midpoint as the point. Okay, so right now I'm writing it d of x is equal to -2x plus c. We want it in slope-intercept form. So I'm going to substitute now my midpoint and solve for c. Once I find c, I'm going to put it together and I'm going to write my equation of this function d of x, which is equal to -2x plus 5. And that is all. So pay attention to the slope that you want. Perpendicular means negative reciprocal, parallel means same slope. If you are dealing with the perpendicular bisector, you want to also include and find the midpoint unless they gave you that value or that point. So keep learning, keep growing, and I will see you in our next video.